PostScript is a new computer language. It was invented and developed by John Warnock of Adobe Systems. And first, it is very important that it is a general purpose computer language, which means you can do anything with PostScript that you can do with COBOL or BASIC or Pascal or anything similar to that. But PostScript very much excels at being able to show words and pictures together as a graphic language. Now, if you want to, you can use nothing but a word processor to create PostScript images. And this, of course, gives you a tremendous amount of power. Now, we kind of adopted a guy called Morale, who's our pouce de resistance here. And this is kind of another example. As you can see, we're combining, in this fairly simple example, text and graphics and some outstanding grays and some fancy curve tracing and stuff. Now, while this could be done with a scanner, in this particular case, we once again have just used a word processor and the PostScript language to do this. My background is kind of an engineering background. I've done a lot of technical illustrations and stuff. Here is a typical example of a drawing in which we have mixed some technical details and some figures and some line art. Now, traditionally, this has been very, very hard to do because one set of people would have to paste in all of the messages. Another set of people would actually do the line art and combine the whole thing. But with PostScript, it draws no distinction between words and graphics, so we can mix in any combination. And a drawing like this, with some experience, can be done in 10 to 15 minutes very easily. This is a logo. And you might ask, is this text or is this graphics? And the answer is it's both, in that we've got, as obviously, our letters, but they're very fancy letters. B did this because she's a weaver, and she gets into a lot of different fibers and stuff. And this is the Cotton Council's particular logo. But the thing is, once you create this as a PostScript routine, you can make it as large or as small as you want to. You can twist it, you can distort it, you can literally tie knots in it. And most important, as it gets bigger, it gets smoother compared to some of the other graphics packages and other systems where as things get bigger, you get what's called a Hershey bar effect, where it starts chunking and going into different blocks and stuff. This is a type of engineering drawing called isometric, and it's primarily of interest to the mechanical drawing type people, and I'm sure you've all seen these as assembly instructions for indecipherable Japanese on a bicycle and stuff. Isometric has the advantage that we can measure in any direction and we can still scale, yet we get an approximation to three-dimensional drawings here. We can do isometric lettering very easily, and not just this nice clean font here, but we can take any font at all, and we'll see some more examples later, and we can draw it in isometric. These lines here, these dotted lines and stuff, it's all fully automatic and all handled by the PostScript language. This is a product. I have an associate called Marcia Swampfelder, and she normally only tends to show up on April Fool's issues. And she's come up with this product that everybody needs. It's poison ivy in a spray can. And it saves having to go out in the woods or anything, just in the convenience of your own home, or if you have a used car dealer or something, you just spray it on and you're all set. If we look a little closer here, we find that we actually have lettering that is physically wrapped around an isometric cylinder. Now, that gets expensive done just about any other way, but with PostScript, it's just very, very easy to take text, and as you can see, fancy text, and we haven't cheated on the lettering or anything. This is a 20th century school book here, and this is Zapf Chancellery here. And as you can see, we've got these two mixed together and put together. And the beauty of PostScript is we have the power to take all these words and we can distort them, we can make them any size we want, we can place them anywhere we want and do just about anything with it. How much does PostScript cost? Usually PostScript is built into a printer such as this Apple laser writer, and we'll look later on to see how the thing works and stuff, but basically the paper goes in here and we have a little thing called a toner cartridge. We'll see a little more on reloading those in just a minute. And the drum goes once around and transfers the toner to the paper, and then the paper will either come out this little door back here, if you like it straight through, or else it will flip it around and turn it up here. And the reason you turn it upside down is to get it right reading if you had a word processor that prints things in order rather than backwards. This particular machine is in the $3,500 class at the present time. Now that sounds like a lot of money, but there are PostScript imitations and implementations available for as little as $200. There are typesetting machines in the high end in the $80,000 to $100,000 range that all use the same language. And so you can start simple and little, and automatically the files you've already got can be moved over. So what can you do with it locally? Here's some examples of what you could do at say a yard sale or a swap meet or something. You can do custom business letterheads, and I'll show you how to do these in full color in just a minute here. You can do bumper stickers. You can do badges using the badge a minute process or any one of several others. You can do business cards, and these can be done on demand. And a person can come up to you and say, well, I need a dozen business cards right now. And you can deliver to them a totally custom business card. And one of the things that I found that works real good with this is to put maps on business cards. Now, if you go to a printer and try to ask him to put a map on a business card, that's real expensive. But there's just so many people who could say, well, here's how to get to our house on a business card map. We also have here a decal. If you look at the decal fairly closely, we see it's backwards. This is intended to go on a peel and stick background for, it goes on the inside of a door on a business, and it's a little more vandal resistant because the vandal has to go inside rather than out. So these are some of the immediate and low cost things that you can do with it. Students and beginning students in my PostScript class, which work with raw PostScript on their choice of Apple or IBM or VAX or Macintosh, are able to, like last night they were all doing resumes and Mother's Day cards and all sorts of things like this. So there's so many things you can do with PostScript that you wouldn't have thought of doing before because you have so much power. This is another example of curve tracing. It's a digitized signature. And with a simple process involving a safety pin and about 20 minutes work and a little bit of practice, you can digitize your signature so that you can automatically sign any kind of routine letters. This is particularly important if you've got a direct mail business or if you're sending out product literature requests and stuff like that. Naturally, you would not want to do this on a legal document. But all we've done here is we've told it to curve trace. And for those of you following some of the stuff I've got in Computer Shopper magazine, we've all even got the ability to simulate pen skips on this thing, so we can make it look very accurate and very good if we so choose to do so. Again, I've come at this from a technical standpoint. This is an example of an electronic schematic. It's a type of circuit that we call an analog circuit, which means it uses more traditional electronic parts like resistors and capacitors and Zener diodes and thermistors and stuff like that. But again, we've combined text and graphics, and if you look at this close up, you'll find that these graphic images are exceptionally well done. And if you look on my hardware hacker column in radio electronics, everything you see there was done camera ready out of the PostScript language. There was never any need for any artwork or any paste up or anything beyond that. Here's another example of a electronic type schematic. What we've got here, this is an example of a digital schematic. You've all seen the little bugs inside your computers and stuff. So we got the schematic, and automatically, once you teach PostScript once how to draw one of these, it will automatically draw it from then on. And you can put these all in what's called a dictionary, and you can just call it out by name, and it will automatically plop this onto a page. So far, everything we've seen has been in black and white. And this looks like just a simple technical illustration, but if we tilt it or move it a little bit, we should be seeing some blue glare on it. And what this is a process called Croy color. And we've got an imitation Croy color machine over here that we'll look at it a little bit. But what is really nice about Croy color, first it works beautifully with PostScript, but you can take any Xerox image from any Xerox machine, and you can make it virtually any of about 65 colors you want. You can laminate with it for such things as menu covers or book covers or menus or stuff like that. You can also simply use it to put a gloss finish on. You can make them gold and silver. This particular one is called a metallic blue and works pretty well. Certificates and awards are unnatural for this sort of thing because we can come along here and we can put a big scroll border. This looks a lot better, by the way, on parchment. But we got this nice scroll border on here. We got fancy lettering up here, and if you look real close, the A and the W and the A here are done what's called kerning, which means we've kind of pulled them in so that the visual balance looks a little better. Again, the whole wagon cover and stuff was just done with a few cubic splines. We got some fine gray. We even have an attempted calligraphy here. There are several PostScript calligraphic fonts. And what these calligraphic fonts let you do is simply appear to be a complete, actually do a signature, and you also have the ability, you don't have to print these up ahead of time, that you can actually have your awards, you can actually go ahead and do things, and then as the awards are announced or as the winners come out in real time, you can generate these. Now I don't have a, do we have a parchment here anywhere or not? Okay, we'll find a little piece of parchment for you here in a little bit. But basically, what kind of papers can you run through this? Some of the papers we can run through the machine. The first and best is just your cheapest Xerox paper, which you get at a place called Price Club or another warehouse store. It's about $17 for 10 reams, which is super cheap. Over and above that, depending on your part of the country, there's a store chain called Paper Plus. Now, out here in Arizona, and we'll be passing around a list here, and we'll give you the main numbers for Paper Plus and the handout that goes with this video as well. But this is a nationwide chain that sells all kinds of magic papers, such as parchments and bumper sticker materials and fluorescent and transparent and peel and stick. And there's all kinds of different things. I guess this is kind of an example of parchment. This is a decal edge thing that they made a Mother's Day card out of it from last night's class. But at any rate, you can get all these special papers and they will run through here. Now there are a few papers that you should not run through. One of these is the floppy disk envelope material. That plastic Tyvek, that melts, and you don't want to do that. You don't want to run acetate through it because, unless it's well supported, because acetate also will melt. But there's a type of transparency material which is called mylar. Its generic name is polyester. And either mylar or polyester will allow you to make transparencies for overhead transparencies or stick-on signs or whatever you want like that. One of the neat things about PostScript is now we can think, rather than thinking graphics or text, we can simply think about having black and white areas on a sheet of paper. This is called a shaft encoder, and it's used by robots, and it normally would go on a robotic arm, and there would normally be things shine through this shaft encoder so it knew its position. And one of the more interesting things about this is out here in the West we have some rather ancient Indian cultures, and there's one in particular called the Mimbres culture in New Mexico, and there's a pottery style from the 1200s called Mimbres black on white that's absolutely identical to this.
That's what I thought it was at first, was an Indian
Yeah.
design.
Mm-hmm. And what it's done, the reason it's this weird shape is as it turns, if you look at it real carefully, you find there's only one thing changes at a time. Because if you had something where two things were going to change at a time and one of them missed by a little bit, it would be really wrong. This is called a gray code. But anyway, if you hired somebody to do this without PostScript, you were talking a good $400 worth of art and layout. You can knock this out in PostScript yourself in about 2 minutes flat, not any problem at all. PostScript makes doing multiples of things very, very easy. Now the most popular thing we'd like to do in multiples normally is business cards, where you would do your business cards 12 up. For the obvious reason, you don't want to have to sit here and send one business card at a time through your machine. So what you do is you print 12 of them at a time, and this of course makes it cheaper and simpler and stuff. I've developed, and you can see them in Computer Shopper, or you can do it yourself with the PostScript language, very powerful step and repeat. In this particular case, this is perhaps some merchant tags or something, but you notice we can sequentially number each of these elements. So we can take, in spite of the fact we're putting them in different positions on a page, we can make little changes to each one, or in fact we can make major changes to each one. So one of the more powerful things, particularly those of you with some of the other programs that have had one image and decide you want to make 4 images in your graphic program and stuff, and you put it on the clipboard and moved it around and then readjusted it and stuff. PostScript can do all this automatically. Some other examples of step and repeater, videotape labels. And what else are we doing with them? Cassette labels, badges. You can put like 4 or 5 badges on the, and so on.
Almost everything we do is step and repeat.
Some PostScript routines let you see what you're getting on the screen. These are often called WYSIWYG, standing for what you see is what you get. But your best PostScripts do not let you see what you're getting on the screen. And the reason is that the more you mess around with the screen, the more restrictions of necessity must be placed into the program that's doing it. So if you're working with your own PostScript program out of word processor, you may not see what you get immediately, but as soon as you print a copy, you know what you get, and there's no rude surprises. At any rate, one of the things we can do that's particularly handy for that is we can put down what's called a rubber grid. And there's this grid background here. And if you look, and those of you in the audience, if you look very closely, you'll find that at each corner here we have exactly and precisely 1 dot. So it's a very accurate and very fine grid here. Normally you would turn the entire grid on and do all your work and layout, and then you would turn the grid back off, unless you wanted to use the grid for a design element, say behind a bar graph or something like that. In this particular case, by the way, this is one of the first block diagrams, the Apple IIgs that was ever published. In this particular case, I've just shown the grid on the bottom so you can see what it looks like, kind of a before and after. So very often you will turn your grid off, but if you want to use it as a design element, it's good enough to let you do so. Now there is one big advantage to the Macintosh compared to any other personal computer, and that's that they had one graphic symbol which all the Macintosh people use very, very extensively. It's far and away the most popular and the most often used graphic symbol. At great time and expense, I was able to move this over to the Apple IIe and over to the IBM environments, and now everyone in the entire community can share this single, most often used Macintosh symbol. I'm sure any Mac people immediately know the bomb icon from the... Anyway, the reason we've really got this here is we're doing some very simple curve tracing using cubic splines here. That this is just a circle which we've clipped the top and bottom of. This is a very simple cubic spline for this highlight. This is a cubic spline, and we've kind of printed it twice. We printed a heavy black first, and then we came back and we printed a narrower gray. This is an example of PostScript's ability to take a pattern and repeat it. In this particular situation, we're rotating, we're coming around. Now we could also repeat by translating. We also have the ability to scale. Okay, here's one that B's done. This is a little printer's tradesman cut. It was intended for a piano tuner. And this particular art style is supposed to be out of the 1920s because it was originally carved out of a block of lead. And I'm sure you've seen all these. And the thing is with PostScript, you can create any style you want in any direction you want. And again, this can be done with graphic programs like Illustrator. It can be done with ordinary word processor. It can be done on any personal computer by any individual. So far, we've said very little about page making. Here's an example of a 3-column page layout that has a header and a footer, figures, and if we look real close, we find it's got some very sophisticated features such as a drop cap. It's got a little wedge kerning going over here. It's got a 4-stage progressive micro-justify. It's got hanging punctuation. You can do stuff like this with the popular page-making programs, but I find that working directly in PostScript, you can put more features in and get it looking better. So my preference is to just use what I call my Gonzo Justify. But again, you can do page making with any of these popular page making programs. Now, one of the dangers of a page making program, as everybody knows, if you've got a hammer, everything looks like a nail. And as a result, there are so many different things that you can do with PostScript laser printing, and very little of them, or very few of them, are actually work well into a page making environment. So the thing is, by all means, use PageMaker or Ventura or one of the other ones to do most of your work. But you'll come up against a limit where you want to make it do something just right or just your way or something. Now, all these programs will allow you to import your own PostScript code to do what you're really trying to do with it. This is an example of a printed circuit layout. I'm sure you've all seen in electronic devices. In this particular case, we've shown the layout grid, and we've shown the foil side in gray, and the component side in gray and the foil side in black. And this allows you very easily and very simply and very cheaply to do low-end printed circuits without having to go to a photo plotter or anything more expensive than that. One thing that architects will find interesting in PostScript is the ability to do true two-point perspective. Now, there are approximately 6,000 bricks in this building, and every one of those bricks is shown exactly right and exactly correct. And those of you that are fans of Adobe Illustrator, I challenge you to do the same thing. This is a little Apple Writer text file. It's about 4K long. And it's very easy for people to learn and use the language on any one of these levels that you choose to do so. The things we do in PostScript do not have to be functional or utilities. Here's a totally abstract design. It's either in the art department or things might want to get into. What we've done here is we've just taken a little bit of curve tracing and we've changed something called the tension on it. And this looks vaguely kind of 1880s or barbershop quartet-ish or something like that. But the thing is, we can also use PostScript as an art tool to do purely artistic or purely abstract or purely explorative type designs. So those are some of the neater things that you can do with the PostScript language. So basically, it's an interpreted language, but at the host end, and you can use any host, all you really need is an ordinary word processor with ordinary words and numbers. The students I have coming in off the street are doing all kinds of resumes are real popular, and badges and bumper stickers, and in fact they were doing prescription pads last year. Prescription pads really seemed popular in our class for some reason. So
I was wondering how much time you save in using this process as compared to basically the old way.
okay, that's a very, very good question, because the old way we had independent people working on the graphics and working on the text. And what we've done here, it is all together. So the quick answer is between 50 to 1, 100 to 1 in time. The other answer is that you're usually doing it yourself rather than sending it across town for somebody else to do it. So as a result, there's a tremendous time savings, and you don't know what you get till you get it back, where here you get it instantly. So in many cases, 50 to 1 time difference. What you can do here in 12 minutes would take you a week by the more traditional process. Yes, you got it, absolutely.
Could you explain more about the PostScript language?
Okay, the language is similar to a language called Forth, in that it is a type of computer language where you will give it the information you need and then tell it to do what it's going to do. Like if I said milk, car, Circle K. In other words, you would know to go to the Circle K in your car and get the milk. But the thing is, we don't want to say Circle K ahead of time, because you would have to come to me and ask me, what do you want me to do with the Circle K? So when we get to the point where we say Circle K, this means that you already have all of this information. So basically, while there is a very complicated PostScript interpreter inside these printers and a very complicated computer, for the longest time the Apple LaserWriter was far and away the most powerful computer Apple built. And it was far and away the most powerful computer that could be bought for under $10,000. So we were talking at the device end, we're talking a super powerful interpreter that takes this stuff. But it's in there, in the printer, and all ready to go. Now all you need to communicate with this is what's called a standard ASCII text file. And that standard ASCII text file just consists of mixtures of words and numbers. The first time you see it, it's a tad unusual in that you will give it the numbers first, and then you will tell it what to do with them. But there are powerful advantages to this. It's called reverse Polish notation. Hewlett-Packard is one of the champions of this, and I understand because of reverse Polish they are going to change their name to Packard-Hewlett. But at any rate, so all you need in your word processor is a mixture of words and numbers. Let's take the simplest PostScript example.
Drive it out of a word processor.
Yes. Now, these doesn't say we just wanted to kick out a page of paper. There's a PostScript command called show page. One word, all lowercase, S-H-O-W-P-A-G-E. And we would run this through, and it would kick the page out. Probably one of the second most, this little paper cassette here, probably one of the second simplest things you might want to do is to do a move to, and we'd have to say where. And usually you work in points, and you work from the lower left-hand corner. There's 72 points per inch, and despite the fact that we're doing 300 dots per inch. Now you can work in inches or furlongs or anything you want, but points is the usual way of starting. And if I want to go to this point, I will say go over 100, go up 700, and move to. And if I wanted to draw a line that goes over 100 points, I would say 100, 0, or a line to. And it would create what is called a path. And then as this path is built up as ordinary ASCII text files, they would then turn around and be sent out to the printer, and then it would actually be constructed and then make as many copies as you like. Okay. So basically it's an interpreted language, but at the host end, and you can use any host, all you really need is an ordinary word processor with ordinary words and numbers. Tremendous opportunities here for anybody, anywhere. You do not have to be a computer person. You do not have to be gonzo programmer or anything like this, but the opportunities here are just mind-blowing. And probably the best way to sum up is what I said before, that the power of the press lies in owning one.